In terms of real solutions to a quadratic equation, there can be 2, 1, or 0 such solutions. In this video, we look at examples of quadratics that have one solution. Let's start with an example. The area of this square can be found using this quadratic function, y equals x squared plus 10x plus 25. Can the square have an area of 10? If not, what is its minimum allowed area? This is the graph of this function, and as you can see, it intersects the x-axis at one point. This means that the quadratic can be written this way. Y equals the quantity x plus 5 squared. This is a much easier form for solving quadratic equations. Notice that y equals 10 corresponds to a negative value of x. So the square can't have an area of 10. The minimum area is shown here, where x is equal to 0. The minimum area for this square is greater than 25. Let's look at another example. The area of this square can be found using this quadratic function, y equals 4x squared minus 48x plus 144. What is the minimum value for x beyond which the square has increasing area? One way to determine the number of roots for a quadratic is to calculate the discriminant, as shown here. The b value of negative 48 goes here. The a value of 4 goes here, and the c value of 144 goes here. Simplifying, we get a value of 0, meaning that this quadratic has one root. The factored form of this equation is this function, y equals the quantity 2x minus 12 squared. When the discriminant is equal to 0, a quadratic can be written as a binomial squared, and you can solve these quadratic equations in your head. Solving the quadratic equation, we get that x is equal to 6, as shown in the graph of the function. Notice that the graph intersects the x-axis at just one point, x equals 6. This is a characteristic of all quadratics with one root, a single intersection point at the x-axis. As you can see from the graph, the increasing values for the area happen for values of x greater than 6. Let's look at a final example. What do you need to subtract from this quadratic function to make it a perfect square? Y equals 16x squared minus 80x plus 105. Where does the graph of this perfect square function intersect the x-axis? Since the quadratic as written is not a perfect square, then we can use the discriminant to find what c value results in a value for 0 for the discriminant. Recall that a 0 discriminant is for quadratics that are perfect squares. Let's input the a and b values into the discriminant formula. The b value of minus 80 goes here. The a value of 16 goes here. Let's leave c as a variable because we want to know what c value gives us a discriminant of 0. Simplifying, we get 6400 minus 64c. In order for that to equal 0, then c needs to have a value of 100. Going back to the quadratic equation, we can add the c term of 100 to this expression as if we were completing the square. Since the original term was 105, we leave 5 outside the parentheses, as shown here. This term becomes a perfect square, as shown here. The graph of the perfect square function shows the single root of x equals 2.5.